this video, we're talking about greatest common factor and how to factor out the greatest common factor from a polynomial. You'll often see greatest common factor abbreviated as GCF, so I wanted to make sure I included it here. And we've got several examples that we're going to work through. What we're trying to do is pull the greatest common factor out of each of these polynomials. Remember that a polynomial means many numbers, or just many terms strung together, where we have whole numbers here and variables multiplied together, and we might have exponents like this. But what we want to do is find the largest value that can be taken out of every term in our polynomial. So in this first example, we have the polynomial 3x plus 9. So we have two terms, one of them is 3x and one of them is 9. We want to find the largest number that we can take out of both of these. Well, we notice here that we have an x multiplied by our 3, but we don't have an x multiplied by the 9. So we know that x isn't going to be part of our greatest common factor because it's not involved in this second term, so we can't remove it from both terms. So that's not going to be involved. Now we look at our whole numbers here of 3 and 9. Well, we know that 3 is 3 times 1, and we know that 9 is 3 times 3. In other words, they have a common factor of 3, so we should be able to take out a factor of 3. Now, once we take out that factor of 3, we have to figure out, what do we multiply by 3 in order to get back to 3x? Well, that would just be x, because when we multiply 3 times x, we get 3x. What do we have to multiply by 3 in order to get back to 9? Well, that would be 3, because 3 times 3 gives us 9. So we're going to go ahead and say plus. We keep the plus here, and then we put 3 because 3 times 3 is 9. Remember, you can always use the distributive property and multiply this back out and say 3 times x gives me 3x plus 3 times 3 gives me 9. I get back to 3x plus 9. So if you're ever unsure about your answer, you can always multiply this back out using the distributive property to see if you get back to your original polynomial. But we factored this completely. There's no common factor between x and 3. We can't take out anything additional. So we know that 3 was our greatest common factor, and we factored this polynomial completely. Now let's go ahead and look at our second example. Here we have 6ab plus 2b minus 4cb. This example is a little bit more complicated because we have 3 terms instead of just 2 like we did in our first example, but the process is going to be the same. So in the same way that we looked for a common factor in 3x and 9, here we have to look for a common factor in all 3 terms, 6ab and 2b and 4cb, and we can only pull things out that factor evenly out of all 3 of these terms. So the easiest way to do this is to look at your whole number coefficients first. So we're going to look at 6, 2, and 4. What's the largest value that we can take out of 6, 2, and 4? Well, that's just going to be 2. Now we have to look at our variables. So we have AB, we have B, and we have CB. The only factor that's common between AB, B, and CB is just B. So we'll take out 2B. We can't take out an A because A isn't involved in our second or third terms, and we can't take out a C because C isn't involved in our first or second terms. So our greatest common factor is going to be 2B, and now we need to figure out, what do we have to multiply by 2B in order to get back to 6AB? Well, what do we have to multiply by 2 in order to get back to 6? That's 3. What do we have to multiply by B in order to get back to AB? That's just A. So 2B times 3A is going to be 6AB, getting us back to our original term. What do we have to multiply by 2B in order to get back to 2B? This one is really important, right? Our greatest common factor matches one of our terms exactly. That doesn't mean that this term completely disappears from inside our parentheses. It doesn't go to 0, it goes to 1, right? Because if we multiply 2b times 1, we get back to 2b. So we always have to remember to include that understood 1. Now, just as we kept our plus sign here, we're going to keep our minus sign here. What do we have to multiply by 2 to get back to 4? That's 2. What do we have to multiply by B to get back to CB? Well, that's just C, so we get 2C. That means that 2B here is our greatest common factor because we can't factor out anything additional from 3A plus 1 minus 2C. So we know we've done this correctly, and if you want to, you can always again use the distributive property to multiply 2B by this 3A plus 1 minus 2C to make sure you get back to the original polynomial. Let's look at another example here. We have 20y squared plus 10y plus 30xy. If we just look at the coefficients in front of each of these terms, we have 20, 10, and 30. We can pull out a 10 as part of our greatest common factor. And then if we look at the variables, we have y squared, y, and xy. The only common factor between those is y. We can't pull out a y squared because even though we have a y squared here, we only have a single y factor in these second two terms, so we can only pull out a y. We can't pull out an x because x isn't involved in the first or second terms, even though it's involved in the third term. So 10y is going to be our greatest common factor, and to get back to our original polynomial, we have to multiply by 2y plus 1 again, remember that understood 1 to get back to 10y here, plus 3x. And that tells us that 10y is our greatest common factor. And we can do this with even more complicated examples here where we have higher degree exponents. So in this problem, we have 8z to the fourth m squared p minus 12z cubed m to the fourth p squared. So the first thing we want to do, as always, is look at our constant coefficients, our whole number coefficients here. We have 8 and 12. The greatest common factor there is going to be 4 because 4 goes into 8 2 times and 4 goes into 12 3 times. So we're going to get 4. If we look at the z's here, we have z to the fourth and z cubed. So in other words, we've got 4 factors of z and 3 factors of z. We can only take out 3 of them, so we get z cubed. We have m squared and m to the fourth, so 2 factors of m and 4 factors of m. We can only take out 2 of them. We have p to the first and p squared. We can only take out 1p. Now, what do we have to multiply by 4z cubed m squared p to get back to our original polynomial? Well, we have to multiply 4 by 2 to get back to 8. We have to multiply z cubed by z to the first, or just z, to get back to z to the fourth. We have to multiply m squared by 1 to get back to m squared, so we don't have to include that. And we have to multiply p by 1 to get back to p, so we also don't have to include that because it would just be 2z 1, 1, or 2z times 1, which is still just 2z. So we go ahead and leave that. We go ahead and leave our minus sign here. 4 times 3 gets us back to 12, so we put that 3 in. Z cubed times 1 gets us back to z cubed. M squared times m squared gets us back to m to the fourth. And p times p gets us back to p squared. That tells us that 4z cubed m squared p is the greatest common factor for this polynomial. And then one last example here, we'll look at our constant coefficients, 5, 60, and 30. The greatest common factor there is going to be 5 because 5 goes into 5 once, into 60 12 times, and into 30 6 times. So we'll get 5 here. We have a squared, a cubed, and a to the fourth. We can only take out an a squared. And if you're confused about that, think about it this way, right? A squared is like this. A times a is a squared. A cubed is a times a times a. A to the fourth is a times a times a times a. So what can we remove from all 3 of these? Well, we couldn't take out 4 a's because there's only 2 involved here. We're too short. So all we can take out then is just the first 2 a's from each of these terms, right? That would leave us with 1 here, that would leave us with a here, and that would leave us with a times a, or just a squared here. So that tells us that we can only take out an a squared. We can take out 2 factors of a, or a squared. Same thing here, we have b squared, b cubed, and b to the fourth. In other words, 2 factors of b, 3 factors of b, and 4 factors of b. Well, we can only take out 2 factors of b, so we can only take out b squared. And then same thing here, c squared, c cubed, and c to the fourth. We can only take out 2 factors of c, or c squared. And so now what do we have to multiply by 5a squared b squared c to get back to our original polynomial? Well, the greatest common factor is exactly the same as the first term, which means we have to multiply by 1 in order to get our first term back. 5 times 12 gives us 60, so we keep our plus sign and we say plus 12. In order to get a squared back to a cubed, we have to multiply by an a. In order to get b squared back to b cubed, we have to multiply by a b. And in order to get c squared back to c cubed, we have to multiply by a c, so we get plus 12 abc. Then we keep our minus sign here. What do we have to multiply by 5 to get back to 30? That's 6. What do we have to multiply by a squared to get back to a to the fourth? That's just a squared. B squared times b squared gets us back to b to the fourth, so b squared. And c squared times c squared gets us back to c to the fourth, so c squared. Now that we've factored completely, that tells us that 5a squared b squared c squared is going to be the greatest common factor for this polynomial. So no matter how big your polynomial is, no matter how big your exponents, the point is look at your whole number coefficients first, and then look at each one of the variables involved in your polynomial and pull out the largest number of factors of that variable that are involved in each one of your terms. The product of all of those things will be your greatest common factor, and then you just want to pull that greatest common factor out of each one of the terms from your original polynomial.